All right, so this lesson is going to be on key features of rational functions. So key features that we're going to be looking at, like the zeros, excuse me, domain, range, the asymptotes, and the end behavior, and increasing and decreasing. And so we're learning about new functions called rational functions. So rational functions, if you remember back to the definition of a rational number, is anything that can be written as a fraction. So the rational functions is anything that is basically a fraction with a variable in the denominator. So like, for example, you can have something like 2 over x. And so because I have a variable in the denominator, that makes it a rational function. And when we have variables in the denominator, there is a possibility of having a 0 in the denominator. For example, like 2 divided by 0. Well, if I take 2 divided by 0, this is going to produce an undefined term. We are not allowed to divide by 0. Like if I were to put that in a calculator to divide by 0, you're going to get something that says like error or undefined values. That's because it is not possible to divide by 0. So it creates undefined values, which is where we get our asymptotes. That's an S. Asymptotes are basically our lines on our graph that create these undefined terms that the graph is getting closer and closer to. It approaches the asymptote, but it will never touch or cross the asymptote. So that's what's special about our rational functions. We'll see our asymptotes, and then we'll have like two parts of the curve. We have, and they're usually like diagonal from each other. And so that's what our rational functions are going to look like. And so we're going to be looking at the key features for that. So if I look at the first example here, I'm looking for the 0. So the 0, if you remember, is the x-intercept. Where's the curve crossing the x-axis? So if I look at the x-axis, the curve is crossing here at the -2. The curve crosses at -2. So I know that my -2 is a 0. And then for the vertical asymptote, that's going up and down from left to right. So I can start from the top. And I'm going to just highlight it in pink so that it's emphasized that that is the vertical asymptote. So vertical asymptote is the one that goes top to bottom, is my vertical asymptote. And so I need to find the equation of that line. So if I look at the vertical asymptote, I'm looking for which value does it hit on the axis. So on my axis right here, I can see it's crossing at this value. So if I notice this value, that's between the 2 and the 4, so that tells me that that's a 3. And then that's on the x-axis, so that tells me that that's an x equals 3. All that means is any of these values have an x value of 3. So this is 3, 0, 3, 2, 3, 4, 3, 6, 3, 8, and so forth. All of these have a value of 3 in the x coordinate. The horizontal asymptote is the one that goes left to right. So this goes from left to right, would be the horizontal asymptote. And so for the horizontal asymptote, I can see it's crossing this value on the y-axis, and that is a value of 2. So that is a y value of 2. Anything on that line has a y value of 2. For example, here -4, 2, -3, 2, 0, 2, this is 6, 2, and so forth. All of these have a y value of 2. And then we have the domain and the range. So the domain and the range, if you recall, domain are the x values, and then the range are the y values. So domain are the x's and the range are the y values. And so if I look at my x-axis, when is this graph defined? So looking at my curve, it's all of these x values going all the way to negative infinity. And it keeps going, and for all of these x values, except I am not allowed to touch or cross that value of 3. But it does pick up on the other side over here of 3, and it goes on forever to the other side. So the only value that this is undefined for is 3. So these are undefined at x equals 3. So the domain is all values except 3. So if I look at the x-axis, it can be all of these values, which are like 2, 1, 0, -2, -4, -10. It keeps going. All of those x values are less than 3. And then I also have this side of my x's. Those x's are greater than 3. So for my domain, I write x is less than 3 or x is greater than 3. And interval notation, that's using the infinities. If I go forever to the left, that's a negative infinity, and forever to the right is a positive infinity. And so starting at the left side towards the right, I see from negative infinity on my x-axis, it keeps going forever until it reaches 3. And then it picks up again on the other side of 3, and it goes on forever to infinity. So for my domain, in interval notation, we're going to write negative infinity to 3 union 3 to infinity. And then the range kind of works in the same way. My range, however, are the y values. So I'm looking at the y values. I have no restrictions all on this side. Anything below 2 is perfectly fine. And everything above 2, I have everything okay. I just am not allowed to be 2. So all of my range values are valid except for 2. These are undefined at y equals 2. Okay, so then I have everything below the below the asymptote. So these are all of the y values that are less than 2, and all of these above the asymptote, which are all the y values that are greater than 2. So for my inequality notation, I say y less than 2 or y greater than 2. And for interval notation, that's the infinities. I have from negative infinity, and then it goes forever to positive infinity, but I'm not allowed to be 2. So I'm going to go from the bottom towards the top, so from negative infinity until I get to the asymptote, which is 2, and then I have to move over to the other side of 2 and go on to infinity. So negative infinity to 2 union to infinity. So if you notice, the relationship between domain and range and the asymptotes, notice that the domain is cut by the vertical asymptote. So that's why I can see the vertical asymptote of 3 shows up in my domain, because I have to cut it at 3. And then for my range is the y values. It's cut by the horizontal. So my horizontal asymptote cuts the range in half. And that's always going to be true. So you can add a note to this on your paper. We can have the domain is basically all of our x values except the vertical asymptote, because the vertical asymptote is cutting the domain. And so this is always going to be written as x is less than the vertical asymptote or x greater than the vertical asymptote. And then interval notation is going to be negative infinity to the vertical asymptote union the other side of the vertical asymptote all the way to infinity. And the range is going to be all of the y values. Instead of the x's is the y values, except the horizontal asymptote. The horizontal asymptote cuts the y-axis in half. And so this is always going to look like y less than the horizontal asymptote or y greater than. And interval notation, we start from the bottom, negative infinity, until we reach the horizontal asymptote, and then pick up on the other side of the horizontal asymptote and go on forever to positive infinity. And then we also have the equations to the vertical asymptote is always going to be an x equals, and the horizontal asymptote is going to be a y equals. So I can see x equals, that goes with the domain of x's, and then the horizontal has a y equals, that goes with the range of y's, okay? So you can go ahead and try this next example. Well, actually, let me just go over this one. In this example, again, the zeros is where it crosses the x-axis. So if I check here, I don't have anything on the x-axis crossing the curve wise anyways. The curve does not touch the x-axis. So therefore, in this example, there are no zeros. I can put NA, or you can put there's no zeros. Vertical asymptote, let's go ahead and try this one again. Vertical is going top to bottom. I'm looking at what value on the x-axis is that crossing. That is crossing at -4. And that is an x value. So I have x equals -4 is my vertical asymptote. And the horizontal asymptote is the one that's going from left to right. So from here I can see from left to right, I have my horizontal asymptote is crossing at the axes over here at 0. And that 0 is actually a y value. So y is equal to 0. So for my domain, it's going to be basically everything except for -4. So I have to cut it at -4. X would be everything less than -4 or greater than -4. And from -infinity to -4, union -4 to infinity. And the range is being cut by the horizontal asymptote of 0. So it's everything except for 0. So I'm going to put y less than 0 or y greater than 0 and -infinity to 0 union 0 to infinity. Okay. All right, so let's now look at this example. You guys can try this. This is the third example on your notes. You can go ahead and pause the video. Okay, hopefully you paused the video, and here's the solution. So I can see in this example, the 0 crossing at 3, x equals 2, y equals -2. Domain is cut by the vertical, range is cut by the horizontal. All right, so let's now go over the rest of it. We got increasing, decreasing, and the end behaviors. So for increasing and decreasing, you want to check from left to right. From left to right, what's happening? So if I look at from the left and I go towards the right, I can see I'm going downwards. And picking back up over here, and from left going to the right, it's going downwards as well. So this is always going to be either increasing or always decreasing. And again, you go from left to right. So starting on the left, going towards the right, it's always decreasing. And for the end behavior, I'm looking at these ends. Technically, there's 4 pieces of the end behavior, but for this year, we're going to focus only on the far left and the far right. Technically, we do have something here going forever upwards, and this one's going forever downwards, but it tends to get a lot more complicated for students, and so you'll probably see that more in a pre-calculus class. But we're going to skip this for this year in a regular Math 3 class. We're only going to focus on the far left and the far right. So if I look at the graph, I am looking at this side over here, the left side. So the left end behavior, we write as x approaches the left side, which is a negative infinity, the function f of x or y is approaching which value? Notice this time it does not go forever up and it does not go forever downwards. This time it gets closer and closer and closer and closer and closer to that dashed line right there. But it's never going to touch or cross it. So it's approaching this value of 2. So this is approaching a y value of 2. It's getting closer and closer to the dashed line. Likewise, on the other side, I have this side over here is the right side. As it gets closer and closer as it goes to the right forever, it's getting closer and closer and closer to this dashed line. And that dashed line right there is 2 again. So we would say as x approaches, the right side is positive, y also approaches 2. Okay, and so if you notice, they're getting close to the dashed line, which we saw earlier, that was the horizontal asymptote. So the end behaviors are always going to be approaching the horizontal asymptote. Okay? So the far left and the far right approach the horizontal asymptote. The 2 end behaviors are always going to be approaching the horizontal asymptote. All right, here's another example just to see another one. From left to right, starting at the left, going towards the right, is going up. Starting from the left to the right, is going upwards. So this thing in this example is always increasing. And then for the end behavior, I have this side, which is the left side. This is labeled wrong. On your paper, it says left. And then this one says right. So the left end behavior, I have this side and this one's the right side. So the left and the right, notice they're getting flat towards the line. And these are getting flat towards the line, which this line here was our y equals 0 for the horizontal. So we would say as x approaches the left side is negative, y is approaching the horizontal asymptote, which is 0. And as x approaches the right is positive infinity, y also approaches 0, which is the horizontal asymptote. All right, so here's the next example. Same example as it was before. This is a practice, so you guys can go ahead and pause the video and try to see if you can solve this one. Okay, hopefully you pause the video. And here's the solution. This one's always decreasing from left to right. It's going downwards. and left to right, going downwards. End behavior, these are both flattening out at the asymptote right here, which is -2. Alright, so now you guys can put it all together and try to see if you can solve this one. So go ahead and pause the video and try it. And when you're finished, come back so you can see the solution. Okay, hopefully you paused the video. So here is the solution. I have the zeros is at 0. The vertical is at x equals 2. Horizontal, y equals 1. The domain, remember, gets cut by the vertical asymptote, which was x equals 2. And then the range is cut by the horizontal, which is y equals 1. And then this function going left to right is always decreasing. And my end behaviors are flattening out to the dashed line, which was 1 for both of them. Okay? All right, that is the end of the lesson. Thanks for watching.